Right, we're doing some completing the square revision now. Now remember that completing the square is all about writing. We write ax squared plus bx plus c in the form p x plus q squared plus r. It's all about writing a quadratic expression in this type of form. Now the reason why it's called completing the square is because we're creating this square of this term here, so that's why it's completing the square. Now the first type are the easier ones. And a typical example might be something like x squared plus 12x minus 3. And we're trying to write that in the form, so we might say something like write x squared plus 12x minus 3 in the form x plus a all squared plus b. In other words, we've got to try and figure out what a and b are by rewriting this quadratic expression. The reason why this is easier, really for two reasons. The first reason is because we've got 1x squared here. Okay? We don't have 2x squared or 3x squared. In other words, we're looking at a equals 1. This value of a here is 1x squared. The second reason why it's easy is because this is a product of 2, of a multiple of 2, I should say. Okay, and we'll see why that's the case. Now remember the basic steps. The first step is we're going to write a big bracket squared, and we're going to add the minus 3 that's already there. Okay, so this minus 3 goes in there. We take our x and we put that there, and the reason why we're squaring this, we get the x squared coming along. And then we half this 12 and put that in there, and we keep this sign the same. If this sign was a negative here, then we'd have a negative here. Okay, it's not, it's a plus, so we keep a plus. But we must remember to subtract, and always subtract, the square of this number here, 6 squared. Okay? Remember always to subtract that square. We're going to tidy up the numbers now. So we've got x plus 6 squared minus 3 minus 36. 6 squared is 36. So we get x plus 6 all squared minus 3 minus another 36 is minus 39. So that's a typical question. Okay, another thing that you could get from this, so let's just say, remember, you can find the coordinates of the turning point. Now they may call that a stationary point, less likely, but you might see the term stationary point. Or you might see it called a vertex. I don't think vertex is a particularly great name for it mathematically, but nevertheless that is used. Basically what we're talking about there is we're talking about the point where this quadratic curve, which is either U-shaped or N-shaped, where this lowest point is here if it was U-shaped. If it was N-shaped, which this isn't, but if it was N-shaped, we're looking for the point where the maximum is. Okay, that's what we're looking for. And how do we do that? So we should remember that, e.g., so we've got x plus 6 squared minus 39. That's from the previous question up here. We should know that if we solve this equals 0, x plus 6 equals 0, that gives us the x coordinate of the turning point, or the vertex. So we just rearrange that by subtracting 6 from both sides. You get x equals minus 6. And we should also remember that we can read this point off to give the y coordinate of the vertex. is minus 39. Okay, so therefore our vertex, or turning point, or minimum point, stationary point, is minus 6, minus 39.